Mr. Kinyanola, and I'm going to teach you today about reflections. So reflections are one of the 4 types of transformations in geometry. There are reflections, there are translations, there are rotations, and there are dilations, 4 of them. So translations, reflections, rotations, and dilations. So try to memorize those, but today this video will focus on reflection. So think for a moment, where do you see a reflection? Yes, in a mirror. So here's a mirror, and you can see the reflection right there of the camera, but let's get a better reflection of this calculator. So we're reflecting this calculator, and you can see the reflection of the numbers. And as I bring the calculator further away from the mirror's reflection makes the calculator appear that it's further away from the mirror, also in the reflection. And if I bring the calculator closer to the mirror, the reflection appears to be also going closer to the mirror. So think of it that way. And look at that 7 in the reflection. It doesn't really look like a 7 in the reflection. It looks like it's been flipped. So 2 things to think about. Reflection, as it gets further, the reflection gets further away from the mirror, and also things are flipped. The images are flipped. Let me give you another example of a reflection. Let's zoom out, and here is a piece of paper. And if you guys ever did this in elementary school, doing ink blots, so here is some paint. I'm going to see if some paint will come out of here. And there's some paint. I'm going to make some kind of weird thing like that. So here's a little circle with a little point up there, and we're going to do an ink blot. If you notice, I folded the paper right here. Here's a fold. Think of this fold right here as kind of like the mirror. Okay, so here's a reflection. Here's this ink blot, and it's going to reflect on this mirror. So what I'm going to do is I'm going to fold it, okay, over this vertical line right here, this vertical mirror. And let's see how that reflection looks like. So I'm going to put it right here. I'm going to do a little blot. I'm going to put some pressure right there. It's going to look a little different because doing that crushes the paint. Okay, so now look at what happens. Here's the original, okay, and then here's that reflection over there. And so let's see if we can notice some things. Here's that line of reflection right here, or that line of symmetry. Okay, and think of the line of symmetry as just where the reflection occurs, or where you flip it. So let's see how far away. Okay, we're gonna take this little point right here, and let's zoom in. So if you guys could see that. So here is the original image, and here's if you could see that fold right there. Okay, let me draw that fold so you guys could see it. There's the fold. And then here is our ruler. It's just about 4 inches. So there's that point to that point. Shows a point right under that little hole right there in the paint. And then let's go over here and let's move it. We'll put the 0 on this ruler, just right under the hole. It is 4 inches away. So a reflection is equidistant. So these two are equal distances away from this line of symmetry. Think of the line of symmetry as the mirror, where the mirror stands and where it's flipped over. So they're equal distances away from here. Or if you think of this part right here, another geometry word you could use is the midpoint. This right here, this line of symmetry, is the midpoint between these 2 images. Another thing is, look how this little pointy thing, it's up here on the right side, and it looks, as we flipped it, now the pointy thing right here is on the left side. So yes, the image is flipped over. Okay, let's do another. So here's another fold if you guys didn't notice. Let me draw a line right here. So here's another line of symmetry. So we're going to fold it over this horizontal line, the sidewaysy line of symmetry. This was a vertical line of symmetry. And let's see what happens. So we're going to do another ink blot. So remember, this is going to change a little as I apply a little pressure, but let's see what happens. So I'm going to fold it over that line of symmetry, make sure it's on that line. Okay, and let's apply a little pressure and see how this ink blot looks like. And all right, so we have not applied enough pressure, but so here's the reflection. So let's use our ruler. Okay, so this one is, so from here, okay, it's about here to here. Okay, so this isn't exact, but just to make the point, from here to here, it's about 3 inches, if you could see that. 3 inches there, and we'll go here to there. It's about 3 inches. So they're also equidistant. Okay, these two images. Okay, so this is an equal distance from here to the line of symmetry, this horizontal line of symmetry, and this horizontal line of symmetry. If you notice, this pointy part is pointing up, and as we flipped it over there, now the pointy part is looking down. So the image isn't exactly the same as if we were doing a translation. Okay, translation, we just move it here without changing the orientation. Okay, but with a reflection, it actually flips the image. So here, with this horizontal line, okay, the image is flipped. Okay, so what's facing up is now facing down. Here, when we reflect it over this vertical line, okay, so here to here, what's facing to the right is now facing to the left, and they're both equidistant from this line of symmetry. So let me show you some examples with points on a plane, so to show you how problems will look like in your class. So here is example number 1 on reflections. So reflect this point across or over the x-axis. So here's our x-axis right here. This will serve as our mirror or the line of symmetry. If you remember, so when we reflect, it'll be an equal distance from here to here, and the same distance will be reflected to over here. So let's figure out how far away point I is to this line of symmetry, the x-axis. So 1, 2, 3, 4, 5. Okay, 5 units away from the x-axis. So what we're going to do is go 5 units away the opposite direction. So 1, 2, 3, 4, 5 units. So here is where our new eye is, and when we move it, when we do a transformation of a point, so this transformation is a reflection, this new point would be I prime. Okay, and just for a good measure, let's figure out what the coordinates are for I and I prime. So this one would be 1, 1, 2, 3, 4, 5. So this one would be 1, 5. And this I prime would be 1, and then -1, -2, -3, -4, -5. So 1, -5. So if you notice, when we reflect across the x-axis, the x's don't change, but the y's, okay, they become negatives of each other. Another thing to notice is, see how we counted, and here's the x-axis. These two lines make perpendicular lines. These make 90-degree angles. Something to think about later on. All right, so here is example number 2. Now reflect across y equals -3. So here's W. We're not going to reflect over the x-axis. We're not going to reflect over the y-axis. It says reflect across the line that makes y equals -3. So if you guys remember how to graph this line right here, if you don't remember, watch one of the previous videos on graphing linear equations, but I'll show you how to graph this. So what we're going to do is make a t-table. We're going to put an x right here. We're going to put y right here. And this will help us figure out some coordinates to graph this line right here, y equals -3. So I'm just going to put some numbers for x. Let's put -1, 0, 1, 2, 3. And whatever x is, what does y have to be? Well, if x is -1, it says no matter what, y is -3. If x is 0, y is always -3. And again, 1 is -3. When x is 2, y equals -3. 3, x is 3, y equals -3. So let's plot these points. So x is -1, and then 1, 2, -3, 0. Here's the origin. 1, 2, -3, 1, -3, 2, -3, 3, -3. You guys get the points. So if we points. So let's just draw a line that goes through all of these points here. So what this problem is really asking us is reflect W over this line right here, which is y equals -3. So how far is this W away from this line? It's only 1 unit. So here's 1 unit away from here. And so let's go 1 unit, okay, in the opposite direction. Or if we flipped it over 1 unit from this line of symmetry, so 1 unit would be right here. So this point would be W. Is it just W? No, it's W prime. And let's figure out the coordinates of these 2 points. Here's W, which is at 1, 2, then -1, -2, -3, -4. So W is at 2, -4. W prime is at 1, 2. And -1, -2, so 2, -2. So this would be our new location when we reflect W over y equals -3. All right, so example number 3 on reflections. Oh, whoa, all right, so reflect across x equals 1. So this time, we're not just reflecting 1 point, we're reflecting 4 points, D, E, F, and G across x equals 1. If you forgot how to graph x equals 1, it doesn't say reflect over the x-axis or the y-axis. It's this line, x equals 1. So let's make a t-table. Let's do x and let's do y. And unlike the previous problem where we put some random numbers for x, x isn't going to give us random numbers because we know no matter what, x equals 1. So let's put 1, 1, 1, 1, 1. We could put random numbers for y because no matter what y is, x always equals 1. So let's do 0, 1, 2, 3, and 4. So now let's plot these points to get our line x equals 1. So when x equals 1, y is 0. When x equals 1, y is 1. X equals 1, y is 2. X equals 1, y is 3. X equals 1, y is 4. So you guys could see the pattern. You guys could see how this line is going to turn out. It's a vertical line because x always equals 1, no matter what y is. Let's use a highlighter so we could see this line a little better. Okay, there's our x equals 1 line. Now let's reflect all of these points. So if you notice, D is already on this line of symmetry, so it doesn't go anywhere. So we could also call this point D and D prime. Okay, E is how far away from this line of symmetry? It's 1 unit. So let's go 1 unit from here in the opposite direction. So this would be E prime right here. F is 1, 2, 3 units away from the line of symmetry. So we'll go 3 units away from here in the opposite direction. 1, 2, 3. So this is F prime. We already talked about D. It's already on the line of symmetry, so it doesn't go anywhere. D prime is the same points as D. G is 1, 2, 3, 4 units away from the line of symmetry. So we're going to go 4 units in the opposite direction. 1, 2, 3, and 4. Okay, and this is G prime. And let's connect those dots. So here is, so from D to G, let's go from D to E, E to F, F to G. So look at that. So here is a reflection. Here is the original. And then here is E prime, F prime, G prime, and D prime. It's flipped over, it's reflected over. You notice the G is on the right side, the original G, but now that it's reflected, the new G prime is on the left side. Okay, F is on the right, okay? So, because we reflected over this vertical line, whatever was on the right side is now on the left side. Okay. And if you guys want to get the points for that, you can press pause and figure out the coordinates for all these new points. And the last example, reflect this triangle across y equals x. So one challenge, maybe the biggest challenge for you, is how do you reflect over y equals x? What does that mean? Does it mean to reflect over the x-axis? No, it doesn't say x-axis. Does it reflect over the y-axis? Nope. It says reflect over y equals x. So if all else fails, you forget how to graph this, draw a t-table. So let's make a t-table. Let's put x, let's put y. For here, it doesn't say x equals a particular number. So we could put some random numbers. Let's put -1, 0, 1, 2, and 3. And let's use these numbers to figure out what x is, or what y is. It says here x equals y. X is the same value as y. So if x equals -1, what does y have to be? They have to equal each other. So -1. If x is 0, and y is 0. If x is 1, y is 1 because they're equal to each other. If x is 2, then y is 2. If x is 3, then y is 3. And let's plot these points. So here's the origin, 0, 0. And here's -1, -1. So we'll go left and down. 0, 0. 1, 1. 1, 2, 1, 2. And 1, 2, 3, up 3. Look at this. So it's not a horizontal line. It's not a vertical line. It's a diagonal. Okay, here's that diagonal going uphill. So let's just draw this line. Here is our line of symmetry. Okay, so now because this line is a diagonal, okay, we want to figure out how far away is this G from this line of symmetry. And so if you guys noticed in earlier in the video, the reflections are, their distances are, they make 90-degree angles, or they're perpendicular away from the line of symmetry. So you don't want to count 2 this way, 2 horizontally, and then go 2 over here, because that's not, that wouldn't make a right angle with here. You don't want to go vertically here and then go down here. This is a diagonal, so you want to do a diagonal away from this line of symmetry. So don't go horizontally, don't go vertically, because this is a diagonal, so go diagonally in the opposite direction, or perpendicularly. So we're going to go G, and how many diagonal units is it away? So from here to here, that's 1 diagonal. Okay, so we're going to go 1 diagonal away from this line of symmetry here. So this would be G prime. So again, let me highlight it for you. Okay, we didn't go sideways or horizontally away. We didn't go vertically, because this is a diagonal line. So we're going to go diagonally this way. So here's 1 diagonal away from the line of symmetry. So we'll go 1 diagonal away from the line of symmetry. So There you go. They're equidistant away from that diagonal line. We'll do the same thing with F to figure out where F prime is. Okay, so diagonal. So, here's one diagonal, two diagonals, three diagonals, and then we'll go three diagonals this way. So 1, 2, and 3. So this is our F prime. And let's go E prime. So 1, 2, 3, and then we'll go 3 more. 1, 2, 3. And this is our E prime. And let's connect these dots and see how they really look like. Well, one thing to notice is that look at these lines right here. They're all parallel to each other, okay? And these lines are perpendicular to the line of symmetry. That means they make 90-degree angles, okay? So that's besides the point. Let's connect these points, E prime, F prime, G prime, the reflection over Y equals X. So from here to here, and then from here to here, and then from here to there. So there is our new triangle that's reflected. So if we did a fold, so if we folded this over this line, okay, this triangle would land right on top. All these points would land on top of each other if we put some paint here and folded it. So these are some examples on reflections. Hopefully this helps. So yeah, have a great day. Here's reflections.